Welcome to Mixed Practice Sequence Questions. So based on the previous video, pause this and try to see, can you solve this problem on your own? They're giving you the 8th and 10th term of a sequence. So we have that the 8th term is 64. We do not know the 9th term, and we know that the 10th term is 100. Now, in the last video, we talked about how if it's arithmetic or geometric, there's basically two types of answers going on here. Two of these answers are arithmetic and two of these are geometric. Now, when you have geometric answers, sometimes you can have a plus or minus if you take an even root. So here, the geometric answers will definitely be correct because you have the positive one and you have the negative one. However, with the arithmetic sequence, the common difference is either positive or negative. For arithmetic sequences, the common difference is never both. So because of that, I know that the mistake or the one that it can't be is going to lie within the arithmetic sequence. So I'm not even going to bother to do this with geometric. I'm only going to do it for arithmetic. And each time I'm adding my common difference to get up to 100. If you write out the formula, that's 64 plus my two skips has to give me 100. You end up with 2d is equal to 36. So that d has to be 18. And remember, 18 is not your answer. That is only your common difference. So I'm going to take 64, add 18, and that's going to give me 82. Add another 18 just to make sure you're correct, and you get 100. So we know 82 works, which means it is definitely not the answer because we're looking for what doesn't work. Now, if 82 is the arithmetic answer, that means the 80s are the geometric answer, and you could have both positive and negative common ratios to give you a positive or negative answer in between. So because the 82 and negative 82 are for my arithmetic sequence, if you know your common difference brings you to positive 82, then negative 82 cannot be your answer. Now, just remember that the explicit formulas are found on your reference sheet. Anytime it's asking you for the nth term, you're looking at your explicit formulas. Now, they're giving you a sequence here recursively because there's two parts, and they want to know how can it be written explicitly because all of these answer choices are one part. Now, before you go from what they have, what you're given to what they have, you can do this a different way. Look, if we tried to do it the regular way, we have our first term and you have your common ratio is 3, right? I know it's geometric because I'm multiplying by 3 each time. If you use the geometric sequence formula, we have a sub n. My first term is 6. My common ratio is 3 to the n minus 1. Now, if you look at all your answer choices, that's not an answer. So doing this by hand is not going to work. You have to figure out some type of trick to get you there. A good trick for this is to figure out what your first few terms of the sequence is going to be. So we're starting with a sub 1, which is 3. I lied, a sub 1 is 6. And then that means a sub 2 would be 3 times 6 to give you 18. A sub 3, your third term, is going to be 3 times 18, which gives you a third term of 54. So you know your terms are going 6, 18, 54. That means if you were to write them as a table, you would have 1, 2, 3, and 6, 18, 54. Now remember, explicit sequences can be put in y equals in the calculator. All of these should go in y1, right? These can all be y's and x's. Now when you put it in your calculator, you're looking for this table. So take a minute, pause the video, put them all in your calculator, and see which one gives you this. And if you notice, choice 3 should work. Let's try the next one. Read the question and see if you can figure out what's the key word. So the key word here is recursive because we know recursive formulas, unlike explicit, have 2 parts. Now that means you can cross out choice 1 and choice 3 because they're 1 part only. I don't even have to read the question because if you look at the other 2 choices, this one, I don't even know what that is. That is no recursive formula, right? However, this guy right here has a sub n minus 1, which we know to be the previous term. So choice 4 is your answer. If you're wondering where the 0.92 came in, they're telling you you are depreciating. That is a 1 minus r, right? Depreciating means to lose. So you have 1 minus your r value, which is 0.08, gives you a growth factor of 0.92. Guys, please be careful here because technically the 0.92 is r, your common ratio, whereas 0.08 is also r, your rate. So I don't know whose bright idea this was, but r means 2 things. R means rate when you're talking about exponential functions, and r also means common ratio when you're talking about geometric sequences. You have to know when we're distinguishing between which one. In example 3, we know that we're talking about the explicit formula because it says the nth term, also because all answer choices have 1 piece of information. So they're asking you which one is the nth term for the following sequence. Now, because this is explicit, you could just put all of them in your calculator. So our first term was 54. Our second term was 18, and our third term was 6. Now you can put all of these in y equals, and you can just look for the table, and you're done. If you want to be a little more mathematical about it and not use your calculator, if you look at all of these answer choices, first off, if you just look at them, choice 1 and 3 are missing the exponent of n, right? From there, if you look at the a sub 1, that's 54. So choice 2 has the wrong a sub 1, the wrong first term. So the correct answer is choice 4. Now, some of us already did this first problem up top in class. If you're good with it, you remember it, just go on further in the video. If not, take some time to go over this problem. You have a recursive formula because it has 2 pieces of information. They want you to find the first 4 terms. In order to do the first 4 terms, you need to figure out what's the pattern. Now the pattern is to add 1 and multiply by 2. Actually, when you're saying it out, you want to do the multiplication first. So you're going to multiply by 2. And then, after you multiply, because of PEMDAS, add 1. So notice how it says the first 4 terms. They already gave you the first one. So you really only have to find 3, which is kind of nice. So a sub 1 is 3. A sub 2, we have 1 plus twice what we had before that, the previous term, which would give you 7. The third term is 1 plus 2 times what came before that, which is 15. And a sub 4 would be 1 plus 2 times what came before this, and that would give you 31. So there you have it, your first 4 terms, 3, 7, 15, 31. And we're not done yet. Now they want to know, can this sequence be represented using an explicit geometric formula? Most importantly, the key word is geometric. You can't write it explicitly if it's not geometric because you need a common ratio. So look at your terms 3, 7, 15, and 31. Can you multiply 3 by a number to get to 7, and then multiply 7 by the same number to get to 15? And the answer is no, there's no common ratio here. And you're done. Please be careful. Do not say that the sequence is both arithmetic and geometric because you're adding and multiplying. If you're combining addition and multiplication, you are neither arithmetic nor geometric. It doesn't work like that. Looking at the next problem, we have in 2010, the population of New York State was approximately that much. Now, they're giving you the population of New York State at the very beginning, right? We're even talking about how many years later. Oh, sorry. We're talking about years after 2010, which means 2010 is your 0 time. So this number right here is a sub 0, your initial term, not a sub 1. Now, they're saying that you have an annual growth rate of 1.5% because you are growing. Keep in mind that this is 1 plus 0.015. So our growth factor is 1.015. And they want to know which equation can be used to predict the population in New York State. Also helpful to know that this is geometric because we see a percent change. So going through these problems, automatically the first one is off the table because you have the wrong growth factor, right? It's not 1.5, that's growing by 50%. If you keep reading this one, choice 2 looks promising, it has a good exponent. However, if you were to write this explicitly, it's a sub 1 times r to the n minus 1, or in this case, t minus 1. This is a sub 0, not a sub 1, so that's not good either. I don't even know what's going on with choice 3 because this is also throwing arithmetic into the mix, right? Because you're adding. But then you're also multiplying, so it's also geometric, so you don't want that one either because it's arithmetic and geometric, which we said before was neither of them. And that leaves you with the last one. You're given your initial term, right? A sub 0, and then they're telling you that each time you're multiplying by a common ratio because this is geometric by 1.015. We're going to skip 3 because that was pretty much explained in the last video, and I want to go on to 4. Now, for 4, there's an easy way, and there is a slightly harder way. Now, the harder way is to do this by hand. So if you were to do this by hand, you can see that each and every time you're actually increasing, which means you're adding 0.75 for each and every term, adding 0.75 each time. And you also have your a sub not a sub 0, you have your a sub 1, your first term. So if you want to model this, because we're adding, we know this is arithmetic, and all these answer choices they all have one piece of information. So all of these are explicit. You can use your arithmetic explicit formula, which is a sub n equals a sub 1 plus n minus 1 times d. Our first term is -8. And our common difference is 0.75. Now, clearly that's not there, so you do have to simplify a little bit. And as you simplify, you're going to get a sub n is equal to -8 plus n minus 0.75. And if you simplify, that's going to be -8.75 plus n. Oh, whoops, I forgot to multiply and actually distribute, which is what I said to do. This should be 0.75. And this should be 0.75n as well. And then once you properly distributed, you see that it's going to be choice 2. Another way of doing this is actually putting all of these in y equals and looking for the correct table. Right? Our first term is -8, second term is -7.25, third is -6.5, fourth is -5.75, so that trick would work as well, only works with explicit, not recursive. Or you could have used in the other piece of information that they gave you, which is that f of 9 equals -2. So if you just plugged in -2 to all of these, sorry, not plugging in -2, if you're plugging in 9 to all of these, which one gives you -2? So you're looking for specifically, when you plug in 9, do you get out -2? And that would be choice 2. So 3 different ways to do the same exact problem. Looking at the next example, automatically before I read the question, I see multiplication going on. So that tells me that this is geometric, which means there is a % rate of change. And because it's less than 1, I know that it is decreasing. And if you want to figure out how much it's decreasing by, 1 minus your rate is going to be equal to that common ratio. And that's going to give you that R is 0.2 or 20%. So again, because it's geometric, cross out the ones that aren't talking about a % rate of change. From there, it's less than 1, so don't choose the one that says it's growing. Choose the one that says it's actually decreasing and that you're having less. Six is very similar to the last video. If you're having trouble with it, check it out. Now, we're going to try one of both. So we're going to work on 8, and we're going to work on 10. So for number 8, they want you to go from recursive to explicit. This is telling us two pieces of information. We have our a sub 1 already, and this is telling me that my common ratio is 1.6 because the pattern is multiply by 1.6. Because we're multiplying, we know it's geometric, so you're going to look at your reference sheet and you're going to find the formula, which is a sub n equals a sub 1 times r to the n minus 1. My a sub 1 is 4, and my r value is 1.6 to the n minus 1, and you're done. Now, look at choice 7. See how that's actually different? Choice 7 is giving you a sub 0, right? That's not the first term, and actually this one's arithmetic because you are adding 5. So that means your common difference is equal to 5. When you go and actually do this, because for the arithmetic formula, you have a sub n is equal to a sub 1 plus n minus 1 times d. You have a sub 1 in that formula, not a sub 0. So you have to actually follow the pattern, right? A sub 1 is equal to 5 plus the previous of 2, which means a sub 1 is 7. So just keep in mind when you do this, it's 7 plus n minus 1 times 5. Make sure you read carefully and you see what they're actually giving you, because with sequences, the notation is super important. Going on to 10, these are explicit formulas. They can go in the calculator, and I highly suggest that you do this. If you were to put this in the calculator in y equals as y equals 5x plus 7, you'll get out your first, second, and third terms. Always do at least 3 terms. That way you could see the pattern. So you have 12, 17, 22. Now, it's pretty clear here that I am adding by 5 each time. I mean, you could have seen that with your slope here, right? Your constant rate of change. But what's more important is that this actually gives you your a sub 1, because a sub 7, I'm sorry, not a sub 7, the plus 7 is not your first term. You actually have to plug in 1 to get out the first term. So now we have everything that's important. Your a sub 1 is 12. And then your pattern, which is based on the previous term, so we need the a sub n minus 1, is you're just adding 5 both times. Make sure you have both pieces, everything that's boxed in, to be considered correct for the recursive formula. Now it's a bit easier to see it in the other one. Right away I can tell that this is my Actually, no, you can't tell that that is your first term, because if you look at your exponent, it's n. Usually, explicit formulas for geometric sequences are a sub n equals a sub 1 times r to the n minus 1. This is only n. So you do have to use the calculator for this one as well. Put it in y equals as 1/5 times 3 to the n. Get out your first 3 terms. It's going to tell you 3/5, 9/5, and 27/5. Now, if you're seeing decimals, that's because you did not use alpha y equals in your calculator. So please make sure you put the fractions in as alpha y equals. That way we get nice fractions instead of disgusting decimals. Now we have our first term. And you can also tell that each and every time you are multiplying by 3, because the numerator stays this, the numerator is increasing by a factor of 3, and your denominator is staying the same. So when you go and write this out, you have a sub 1 is equal to 3/5, and the pattern, which is based on the previous term, is to multiply by 3. So take the time to go back in this packet and complete the questions that we skipped, and then check your answers with the answer key on Teams. All right? That's all for this video.